Hi everyone, welcome to my channel. This is Mr. Cervone. For today's do now, for number 1, the slope of a line is -2 and its x-intercept is the point 5, 0. What is the coordinate of its y-intercept? So there are different ways to proceed with this problem. Here we have a slope and we have a point. So we might want to use the point-slope form here, or we can use the slope-intercept form, either way. So let's say we want to use the slope-intercept form here. So the slope-intercept form is y equal to mx plus b. And in reality, this is the value we want to find. We want to find the b value, okay? That is the y-intercept. Okay. So we have a point at 5, 0. So we can say that the x coordinate is 5 when the y coordinate is 0. So we can say that 0 is equal to, so we know that -2 is the slope. So it's -2 times 5 here, and then plus b, okay? So that means that in this case, we have 0 is equal to -10 plus b. Therefore, b has to be equal to 10. So we actually found the answer here. So let me write this down, that the y-intercept is equal to, so we have an x value of 0 and a y value of 10. And that is the answer. That is the x-intercept. If you're interested in writing out the equation, it would be y is equal to -2x plus 10. And that is the equation. But anyways, the answer is 0, 10. Okay, what about number 2? How do the graphs of the line 2y minus x equal to 12 and y equal to half x plus 1 compare and differ? Well, there are a few things we can do here to compare them. First of all, let's look at the algebra first, okay? So what we can do here is take the first equation, 2y minus x equals to 12, and convert that to the same form that is shown over here like this in slope-intercept form. So maybe we can see, okay, how do the slopes compare? How do the y-intercepts compare? Okay, so in order to convert that to a slope-intercept form, we want to first add x on both sides of the equation. So here we have x plus 12. So now we can divide by 2, and we have y is equal to 1/2 x plus 6. Okay, so the second equation, so let me call that y1. So y2 is equal to 1/2 x, but now we have plus 1, okay? So now we want to compare these two, okay? So we can definitely see something here, okay? If you look at the, let me use a different color here. If you look at the slopes here, both of these have the same slope, okay? And we're going to see how these look like on the graph. But the only thing they differ is with the y-intercept, okay? So how do these two graphs differ? Okay, so let's graph this in the calculator. So the first thing is to input the equation. So let's open parentheses. Here we write 1/2 x, close parentheses, we put an x, plus 6, and then enter. Okay, so now we input the second equation, 1/2 x, and then plus 1. Okay, hold on, there's an x over here, okay, and then plus 1, enter. Okay, once we're done, we hit graph, and we're gonna see how these compare. Okay, so that's the first equation where the y-intercept is at 6, and that's the second one where the y-intercept is at 1. Okay, so what can you say about these two? Okay, so here's a better view. What we can say here is, yes, they do have the same slope, therefore the lines are parallel. And with that, we're actually introducing our first theorem for coordinate geometry. and here it is. If two lines have the same slope, then they're parallel. Okay, so this is a theorem. What this means is that we can prove it. Remember that here we have an if-then statement, okay? So in an if-then statement, we have the hypothesis, okay? Two lines have the same slope. Remember that that is called the hypothesis. And we always assume that the hypothesis is the true premise. So we know that the true premise is that they have the same slope. And their parallel is the conclusion. So the question is, how would you prove that if they have the same slope, then the lines are parallel, okay? Okay, so let's look at a drawing where the lines are labeled and some of the points are defined, such as A, B, C, and D. So according to this, we're giving that slopes L and K are equal, okay? So let's first define the slopes here. So if you look at slope L, okay, slope of line L, that is equal to rise over run. So in this case, the rise is CD, okay, and the run is BC, okay. In a similar manner, we can define the slope of line K, which is equal to the rise in this case. So the rise in this case is AB, and the run is also BC, okay? So what can we do now? Well, we know that from the given that the slope of line L is equal to the slope of line K, by substitution, comma, we can actually say that the ratio of CD over BC is equal to the ratio of AB over BC, okay? All right, so there's something we can conclude here. Because they both have the same denominator of BC, we can conclude that CD has to be equal to AB, okay? All right, so if you look at these, right? So you can actually imagine that these are triangles. Okay, so let me actually highlight these a little bit better here. So there you go. So here we have this triangle here. Okay, if you look at this triangle, and you can look at the other triangle here. Okay, so we have two different triangles here. You can also look at it as a parallelogram if you would like to. Okay, but let's look at the triangles. We know that CD is equal to AB. Okay, we can also say that therefore segment CD has to be congruent to segment AB. Okay, so if you look at this, this is congruent to this segment AB. Okay, all right, so we also know that segment BC is congruent to itself. So let me write this down. By reflexive property, okay, we're going to say that segment BC is congruent to itself. Okay? All right, so we do have now a side here, and we have a side here of the triangles. Okay, either we need another side or another angle in between. We actually do know that this angle is congruent to this angle. Well, how do we know that? Well, the thing is that initially, when we drew it, and I should probably specify it here, maybe let me write this here, actually from the first steps here from the proof, you draw segment BC, or actually segment CD, such that it's parallel to the y-axis, okay? And similarly, you want to draw, we're drawing segment AB, okay, actually segment BC, also parallel to the x-axis, okay? Okay, so this is a condition that we're going to draw them. Now, we also know that since the x-axis is perpendicular to the y-axis, That's just also an initial condition. And we know all of this, right, that we had before. CD, or segment CD, is parallel to the y-axis and BC is parallel to the x-axis. Since all of this, comma, then we can conclude that segment CD and BC are perpendicular, okay? CD perpendicular to BC, and similarly, we can conclude that segment AB is perpendicular to segment BC, okay? All right, so we can conclude that, and therefore, we can say that the angles, so let me call it angle BCD, and now angle established by these perpendicular lines, let's call it angle ABC, are right angles. Okay, so they're right angles like this. Let me actually write like this. By the definition of perpendicular lines, okay? Now, since these two angles are congruent, they're actually, okay, since these two angles are right angles, therefore, angle BCD is congruent to angle ABC, okay? So that's because, all right angles are congruent. So now we have another angle here. Okay, so now look at this. We have the following. Let me actually use a different color here again. Okay, so we have this. We have a side. We have another side. And we have an angle here, okay? So what can we say about the two triangles? Okay, so if you look in the figure here, the two triangles must be congruent, okay? So let me say, therefore, triangle, let's call it triangle ABC, has to be congruent to triangle, and let me call that other triangle DCB, okay? DCB, okay? And the reason is what? The reason is the SAS postulate. Okay, so now that we have established that the two triangles are congruent, what can we say about the angles or the corresponding parts? Well, they also must be congruent. So now we have to be careful which one we pick. For example, in this case, we want to pick this pair of angles here, okay? Because we're going to use BC as the transversal, okay? So let me actually first write this out. So that angle ACB, so angle ACB must be congruent to, well, if you look at the order, ACB should be DBC. So let me check here. So we have DBC, and that is correct, okay? So it's equal to angle, or congruent to angle DBC, and the reason is corresponding parts of congruent triangles are congruent. Also the famous CP/CTC. Okay, so now that we know that the angles are congruent, let's go back to the image here. So let me erase some of the things here so it's not too confusing. So here we established that these two angles are congruent, okay? So if you look at this, so here we have a transversal, okay? And these are the two lines L and K. As a matter of fact, we know that the two lines L and K must be parallel because the two angles are congruent, okay? So therefore, let's conclude, therefore, line L is parallel to K, okay? And the reason is the following. If two lines are cut by transversal and alternate interior angles are congruent, then the two lines are parallel, okay? So there you go, we proved that if two slopes are equal, or the theorem, if two lines have the same slope, then they're parallel, okay? So we proved the theorem, and now you're free to use it in any of the proofs or algebraic problem. To conclude this lesson, let's look at a problem where we can apply this theorem, okay? So a line L goes through point 3, 8. Then another line K goes through the points -2, 5 and -5, 9. Find the equation of line L such that line L is parallel to line K. Okay, so how would you do this problem? Okay, so the first thing we want to find is the slope, because we know that the theorem that we just proved also goes in the reverse direction, okay? We can also state that if two lines have the same slope, or if two lines are parallel, then the two lines must have the same slope. Okay, so let's find the slope, m, of line K in this case, okay? So the slope is established by these 2 points over here. So we're going to say that it's 9 minus 5 divided by -5 minus -2, okay? So that means that here we have 4 in the numerator. And in the denominator, we're going to have -5 plus 2, okay? So we end up with 4 over, and -5 plus 2, we end up with -3, okay? So that means that m of k, or the slope of line K, is going to have a slope of -4/3. Which means that since L parallel to K, comma, m of L must be equal to m of K equal to -4/3, okay? So that means that the equation, let me call it y sub L because we want to find the equation of line L, okay, is going to have a slope of -4/3 and then x plus b. Now, how do we find the y-intercept? Well, simply we just need to input the point here, 3, 8. That means that this is going to be 8, the y value, and then we have 4/3 or -4/3 times the x value of 3 and then plus b, okay? So if we do the math here, we get 8 is equal to -4 plus b, and therefore the b value is going to be 12 because we're adding 4 on both sides. So therefore the final answer is the following, that y sub L is going to be equal to -4/3 x plus 12. And that is the answer, okay, right here. Again, I would always double check this if it works. You can input the point 3, 8 and see if it works. It should actually work. And other than that, that's basically it, okay? Okay, I want you to please complete your homework assignment. Please check Schoology. That's going to be due on Wednesday, April 29. If you have any questions, please email me or post a comment on YouTube. Other than that, thank you for watching and have a great day.